afternoon, everyone. We have a nice mix of panelists here, all experts in their own individual fields. So, what I will try and do is bring out their ideas when I ask them questions, and probably that will all add to our knowledge base, right? So that's the idea here of sharing our experiences, our knowledge, and try and see where we are headed with the data center industry. As the title topic suggests, we are discussing about the cooling technology, what we see coming in the coming years. Some of them, maybe you have heard in the morning, but believe me, we'll all have a different perspective to it. Although the title says it's about Mumbai, but the technology is universal, as we all say, so it doesn't matter whether it's Mumbai or Madrid. The cooling technology probably remains the same, right? So with that, what I will request is just everyone to please give a very quick introduction of yourselves. Sir, start with your mic. Go ahead.
Is this working? Yes. Good afternoon, everybody. Liam McDermott is my name. I'm a global sales development manager with Grundfos, and Grundfos are a water technology company. Pumps are our main production, but we're involved in pumps and pump systems, water treatment systems, and whatever. You can probably take from my voice that I'm from Ireland. I arrived in at 4 a.m. this morning, so I'm a little bit tired, but I'll try and stay awake for the discussion, and I hope it's going to be a very good discussion. Thank you.
Good afternoon. My name is Madhur Sehgal. I am heading the sales for the Climate Solutions division of Danfoss. Obviously, I am not representing only Climate Solutions because we have 3 divisions in India, and today in data centers, we are offering our solutions from all the 3 divisions, like compressors, heat exchangers, all kinds of controls. We are also having flexible hoses for the liquid cooling systems, and we are also having variable frequency drives for the fan coil units. So I think we'll be happy to share my insights during the session. Thank you.
Great. Yes, sir.
Hi there. Good morning. I'm Roy Samuels. I'm from CBRE, Data Center Solutions. I'm based in Singapore, although I live in Australia. Glad to be here in Mumbai. We have a large team in Mumbai. We manage over 900 data centers all around the world. We manage, we operate, and we maintain. In APAC, we manage over 105 data centers for our customers, both DC operators, colo, and end customers as well. I'm really glad to be here with this esteemed panel to talk about cooling in the 2030. I'm a mechanical engineer, come from a design background, and now I work in the operations arena. So looking forward to this discussion. Thank you.
Hi, good afternoon, everybody. First of all, thank you for making time and allowing us to present our views to you all. Right, my name is Rajgopal Naik. I work as the CTO, CISO, and CDPO at Metro Brands Limited. Metro Brands is a primarily offline footwear retailer. We operate 850 plus stores across the country under the brand names of Metro Mochi, Walkway, Crocs, FitFlop, Proline, Biofoot, Fila, Shoe Depot, Foot Locker. Hopefully you own more than one or more pair of our footwear. Right? Once again, thank you for your business, and I look forward to contributing the knowledge that I have out here. Thanks.
Hi, good morning, everyone. My name is Christopher Leahy. I'm working with Dermott. Dermott is a multinational engineering design consultancy. We're present primarily in EMEA, founded in the Netherlands, and we're also present in Latin America and also here in Mumbai, with an office opened recently. I'm looking forward to taking part in the discussion.
Thank you all, gentlemen. So, Christopher, I will start off with you. You being the design guy, So let me ask you, how do you see the data centers evolving in terms of the cooling requirements generally, and in particular, if you are aware, then in Mumbai, what do you see?
Yes, I suppose when I looked at the title of this discussion, looking at 2030, which is, let's say, 6 years from now, 5, 6 years from now, I thought back to 5 or 6 years ago. And I thought, I wonder what we thought was going to be happening by 2024. And I don't really think that many of us could have predicted accurately where we would be. And even just browsing through the expo area outside, and we're moving from 10 kilowatt racks up to 132 and up to 250 kilowatt racks that we're speaking about now. That gives us an idea, I suppose, of where we'll be in maybe 2 or 3 years' time. I think going beyond that is quite difficult, but in terms of where we're at with design right now, what we're seeing, and this is across Europe and also in this part of the world, is that the reality right now are hybrid systems. We're mainly in air-cooled systems right now, and the design is primarily with that. A lot of the hyperscale data center providers and co-locators are now looking at hybrid systems. They're looking at provisions, but they know that it's heading in that way. I'll just give an example for one client that we have. We're developing a 24 megawatt hyperscale in Milan, and we did REBA 2, REBA 3, and REBA 4 we've done at least 3 times. Apart from we went into a value engineering exercise, but now that the customer is coming on board, we're looking at, again, because they're looking at some requirements for liquid cooling. So it's very much driven by new cooling technologies, innovations, and what is current, and how can we try to get ahead of the curve. That's where we're looking at it from a design point of view.
So it pretty much validates, the fact that customers are universally the same, and iterations and tweaking of the designs is a constant ongoing process, right, until you deliver.
Absolutely.
So Roy, coming to you, do you see the same things happening in the APAC region generally?
Yeah, I think the trend is global. APAC is an area that's grown very, very quickly, and the technology has leapfrogged. So we're still seeing that the hybrid model that is coming in, which goes into rear door cooling or direct-to-chip. People are talking about immersion cooling. From what we are seeing in terms of the adoption, that the direct-to-chip is the next step. Definitely liquid cooling is coming, and it's already here. We already operate data centers that are running on direct-to-chip, and that's just going to increase. A lot of this is coming from the customers, which are hyperscalers, which have a huge AI demand in terms of their processing powers. And if you read the news in terms of NVIDIA, where they're going, in terms of the type of chips that they will be putting in your data centers, that's the trend we're seeing. In India itself, it's already coming. There are some demonstration projects that are going on as well to look at that, but it's going to catch up very, very quickly. So we have to be ready for that.
Okay, so pretty much universal trends in there, right? I'll come to you, Mr. Rajgopal, to just understand, what kind of data centers you have, or are you outsourced, and do you think that you will also go through a challenge of cooling your data centers?
Yeah, so currently we operate on a hybrid mode. It's a combination of co-location and AWS cloud, right? And like every other company, we are also heavily looking at leveraging AI to drive efficiencies and also build the next level of services and improvements that we look at. Now, what happens is that, across the industry, I see a trend wherein beyond a certain scale, okay, it might be more cost efficient to have your AI workloads running on your own data center, and that's when we will, have a need for liquid cooling technologies or direct to chip like DCLC based systems. And over there also I see that right now, where there's a focus on higher compute density racks leading to higher cooling requirements per rack. I'm sure there's a lot of smart money going around how we can on a per watt basis get more compute out of systems, and that will be the game changer. Beyond a certain point, the kind of cooling that you put in place may not be sustainable. Thanks.
So what kind of rack densities are you envisaging, sir, going forward?
So right now I don't have much of a view on it.
Okay.
Right? Because we are still in the love for the cloud right now.
Oh, okay.
Time will tell. Thanks.
No worries. So, okay. So now, what I see is that hyperscalers are the ones probably driving up the rack densities. And if I were to ask you, Liam, by 2023, what are the kind of rack densities you envisage and how would you propose to pull them?
We're getting a lot of information, and we can kind of see a roadmap that's coming from the chip manufacturers, saying that rack densities are going to, be above 100 kilowatt, 200, 400. We've been told megawatts in rack density, which is quite scary. I mean, to think about a rack that's a 1 megawatt rack, how do you cool that? It's impossible to cool it with air. But at the same time, you are going to need air there, which brings us to the hybrid type of cooling. It's going to be a liquid cooling of some sort, and direct-to-chip really seems to be it. One of the big things that I can see that I'm hearing is, the loads on these chips and the fluctuation of loads. Do we throw loads of liquid at it and keep it, cool? And that's going back to an old way of doing things where we're wasting lots and lots of energy. Or do we find hydronic ways of doing it where we can cool at the right time, at the right place, at the right source? And I think that's going to be a big challenge. And I think a lot of research has to go into that in the near future. And how long is this going to take? Is it going to be 2030 or is it going to be 2033 or is it going to happen sooner? Because, as has been said before, the roadmaps are there, but really and truly, it's things are developing so fast that keeping technologies up with it are just, they're really a challenge. I've heard some people say that the cooling technology is holding back the computing technology. We're not able to cool the technology that's already there in the right fashion, so we need to keep up with it in cooling.
So, coming to you, Madhur, you are in some way responsible for cooling the data centers, right? So, with this kind of challenges coming in, I mean, what do you see as a probable solution or the most likely solutions going forward?
Yeah, so I think many people have already spoken about hybrid cooling, which is a combination of air cooling, then we look at liquid cooling, probably free cooling is also an addition to that. If we look at the air cooling today, we are working in the, when we look at the temperatures, we are looking at inlet temperatures of around 24 degrees centigrade. Now, how to raise the bar and take it to 28 to 30 degree? Technologies are available today. So when I say this, and when we look at the subject today, I think 2030 is, in my way, too far. I think the technologies are already there. It's all about how fast we can adopt that. So first step is to look at the inlet water temperature. If we raise that bar, there are solutions available. We need to move away from the conventional cooling systems, which is like conventional screws, to oil-free chillers. So there is an option available where you get the highest level of efficiency. You can increase the COP and you can reduce your PUE from 1.48 to probably 1.25. So that's a clear advantage. When we look at liquid cooling, obviously there are many options available. What we see in the industry today is that there is a knowledge gap, and how to really transfer the knowledge to the technicians who are really going to handle the product. So I think that's where I think the industry has to join hands together and work on to really pass on the knowledge. And we need to really work very, very closely to really employ these technologies in a staggered manner. I think that's one of the areas we can look at. And that's where also the solutions are available today. Another aspect when I look at the air cooling itself is how we can utilize EC plus fans. Because we are today still using conventional fans. Because these are the things which simply can improve your efficiency. And you can simply increase your efficiency level, reduce your energy consumption by 20%. So these are some of the areas which are clearly visible to us, which can immediately give you some advantages.
Okay, so that, Christopher, I'm just, coming to you because this gentleman triggered off a different aspect of the cooling, which is efficiency, right? So my question is that, do you see, challenge in cooling that density, or do you prioritize efficiency? How would you approach as a designer?
I think it has to go hand in hand. I think there's no.
Ideally, yes.
What's very good to see even here is that from now on, let's say the development and the future development of racks is being done together with the cooling methods. It's no longer something that's separate that you think about cooling it afterwards. Some other guys, the mechanical guys, will come in later and cool it down. Don't worry. Now it's being done together. So we're developing chips that can be immersed in different kinds of liquid with lower boiling points to try to create more efficiency. So I think, and another element I suppose that's hugely important for data center developers is sustainability. That's one of the main ticket items when we're talking about, obviously, time to market. There's a lot of drivers, but also efficiency and sustainability. And again, these, let's say, issues and these solutions go hand in hand. They have to come together. They have to come together also bringing in AI, machine learning, where we can be much more efficient in running our machines. They're not running with 40% efficiency or something like that. Because we can get closer to where the issues are, power things down, power things up, according to the demand. That's where the efficiencies will come in. And of course, that goes back to all of the various different components that make up the systems. They all have to be equally efficient, monitored and tracked.
So, let me ask you this, Roy. A different perspective, do you think these densities are actually going to hit us before 2023, or it's a long way away, or we are already deploying them? How is it in the region?
Okay, I think the question is how long is the string, and how can we forecast? From what we know, as we see today, definitely by 2030 you're going to be calling using liquid, and I think that's a given. How fast we get there is really dependent on a number of factors, and is being driven by the customers at the end of the day. We in the industry are reacting to the chip manufacturers. I go back to what you were saying. I come from a design background, so it was always the chip manufacturer or the server manufacturer will say to the engineers, "This is what we need to do. You need to design to go away and do it." And we could do it because within the engineering technology that was available, it was easy to do so. Not anymore. Okay, we've already gone past air. We cannot cool the kind of demand, the rack densities that we are looking at today. So it's one of those things as to how fast, and it's going to be driven by, I believe, the hyperscalers. They're the ones who are going to drive how fast we're going to get there. And it's going to be a very quick learning exercise. And one of the things that I want to just quickly add is we're only talking about technology right now, what's available, what is the supply chain. There's very little talk about operations. Okay, and that's where we come in. We have to run, maintain, operate these data centers for the next 30 years. And right now, there are no trained people because it's technology that's going in. We are learning. And the more time we will have, the more we learn. However, I think the good thing is that at least the collaboration that's happening with the chip manufacturers, etc. When you talk about, the type of densities we're talking about, 1,000 kilowatts. You as an engineer, you'd say, "Will one day I fry one of those servers in your cabinet? What will happen?" So there's still a lot of questions that we need to address as an industry. But just to answer your question, it's definitely going to be liquid. Whether it's the next 5 years or 3 years. And I would like to say that it's going to be more like 3 years than 5 years.
Yeah, that's what it looks like, right? So, okay, one more, a kind of a tangent question, I would call it. What are the high density racks trying to achieve? Are they trying to maximize profit, achieve efficiencies? I mean, what's the end purpose of packing in so much power in a rack? Any thoughts around that, Roy?
Okay. CBR is a real estate company, so although we just breathe and talk data centers, so it's about real estate, but in terms of the space that's required by a server rack, how much space it takes. So if you can stack more racks, you're making good utilization of that real estate that you're holding. At the end of the day, it's about profit. Let's be very frank about it. We're all in a business to make money, but we as engineers need to look at sustainability. That is important to us as a community as well. So there's going to be a balance between commercial profit versus environment, community. Thank you.
Thank you. So, Mr. Rajgopal, how much of a focus or commitment you have on the sustainability part?
I think sustainability today, for all organizations is a key tenet that is there, and something that directly or indirectly impacts all of us, right? Even when you go to any of the hyperscaler, all of them have their own sustainability report with respect to the workloads that you are running, right? In terms of the quantum of carbon credits or carbon CO2 emissions that are related to that. Now, it goes without saying that to be more profitable in a business, one has to be sustainable in the long run, right? And this gets helped by changes in technology that come in. For example, everybody is talking of liquid cooling, direct liquid cooling, but if you go back to the basic principles of your physics and chemistry, the maximum heat absorption or release happens when there is a phase change, right? I also see that by 2030, there will be some technology, okay, which uses the whole concept of phase change for cooling. Right? Today we have, that happens in all our homes with our air conditioners that are there. But something that is directly close to where the source of heat is what will drive efficiency and thereby reduce the total cost of ownership and the impact on environment. Thank you.
Yeah,
I just wanted to add that. So what we talked about was, liquid cooling, but as I said, there's various forms of it. And immersion is the ultimate answer, it seems, at the moment. How we get there in terms of the adoption, because that's a totally different data center design, totally different demand, etc. And again, it's an area that is still developing. So when we talk about sustainability, that's where we're going to go to. And again, it's about how fast we get there.
Right.
But definitely, you talked about phase change, single stage, two stage, etc. That's where we're heading.
Right. So now, sorry, please carry on.
On the sustainability front, I would like to add a different dimension because data centers, we use chillers, so there is a lot of refrigerant. And when we look at the refrigerants today, I think that's where also industry has to work on, because we need to move away from the very high GWP refrigerants, which are really impacting the environment. And we need to move to the low GWP refrigerants. Again, technologies are available. They are being employed across the globe. Many European nations have already moved to that. So we can really kickstart that movement as well. Because when we look at the refrigerants today, what we use is R134A, which is having a very, very high GWP. And we need to really take larger steps now to move towards refrigerants like R1234ZE, very, very low GWP and really, really safe for the environment. So these are some of the steps. Another step is really need to change what kind of heat exchangers we are using in our chillers today. Because there are technologies available like microchannel heat exchangers where you can bring the refrigerant charge reduction by almost 40%. So both these combinations together can give you a much, much more sustainable product.
Right. So sustainability brings into my mind one more aspect which we don't generally discuss, which is water. So I don't know how will the new cooling technologies which we are envisaging to come, how much of a water they will use and what kind of conservations we can do. And this is open to all of you. I would like to hear all of your views here.
Well, if I could start with that, and I think we need to look at water fit for use. So, it is a water intensive technology, and traditionally we're using town water or drinking water or whatever as our cooling media. But there are a lot of other sources there that we could be using. In certain areas, well, obviously recycling is one of them, rainwater is another, and then if you take wastewater, which could be sewage, other forms of wastewater, there are loads of technologies available where we can clean that, use it, and then we're not competing with the population really for the water sources that we're already using. And I think we need to be really, really sharp on that. The technologies are there, we just need to start implementing them.
So just on that, I think there's already a trend, and in the designs that we see is moving away from technology that uses a lot of water. Some of the major customers within the environmental policies will restrict the use of water-based technology. So if you look at where we're going with direct-to-chip, right, although we are using water at a high temperature, it still gets heat, rejected through cooling towers, which use up a lot of water. So we are seeing designs where dry coolers are being used instead of cooling towers. Legislation itself, in some countries that we operate, you're not allowed to use cooling towers, per se. So water is a very precious commodity, and it'll become more as we go along in the industry. So it's something that we need to address from the design stage.
So Christopher, your views on the water consumption?
Absolutely. It's, I suppose there is more of an interest in air-cooled chillers recently, which have a very limited water use. Obviously, it's more recirculation, and I think that's an excellent technology in terms of reducing water use. But if one more on the sustainability element, an interesting example that comes to mind is one of our projects again in Milan that we're working on, where we're working with the local utility company to provide a district heating system from the heat rejected from the data center to the local community. And I can imagine when we're speaking about a city like Mumbai, where there's such a huge population, a huge density of people, and within an arm's reach of any data center, you're going to have the possibility of reusing that heat. And not only is it regenerating the heat almost for free, but it's also giving back to the community. I think one of the things that the data center industry suffers from is a sort of a separation from the community, and it's looked at almost like a bad word. We're beginning to understand that, okay, yes, everything we do on our phone, which is almost everything, needs those data centers, but it's also important, I think, to just bring those things back together and understand how it can give something back to the community. Maybe there's less necessity for heating systems in Mumbai, but that's something that definitely the data center industry, I think, is moving towards.
Yeah, I think that's a good point, and that's my next query here. Data centers are looked upon as, using up all the electricity, which is then not available for the common man, kind of. That's the perception. This all new cooling techniques, while they may serve the purpose of cooling the high density racks, are they, efficient in terms of the cooling vis-a-vis the power they take? Say for example the COP of a chiller or whatever matrices we use. So for example, a 5 megawatt data hall cooled in a present technology, which is a fan wall or whatever other means we have, vis-a-vis a 5 megawatt of, say, a liquid cooling, for that matter. Would it be more efficient or less power consuming? Let me ask that. Any ideas around that?
I have a bit of a different view on this. I think when you look at sustainability, at the end of the day, it's about reduction. You want to see where you can reduce the energy usage. So I put the onus on the chip manufacturers. How efficient are their chips? Why do they need such high densities to produce the workloads that they're doing? That's where it's going to start. But that's a hard sell as well, right? So to answer your question, yes, there are technologies available, depending on the designs, and my design consultant colleagues will tell you, no one data center is the same. It has its challenges, depending on the type of customer that you have there. Technology will still keep building. When you look at COPs or chillers, it's improved dramatically, etc. We're looking at also renewable energy to meet that demand. But I think we should all, as an industry, see how efficiently we use that power to generate the workloads that are coming through the data centers.
Yeah. So, Liam, any particular directives or ideas going on to make your equipment, more energy efficient than what they are today?
Absolutely, yeah. We're looking at all aspects of pumping. So we're taking the product pumps, the systems of whatever. We're taking how we distribute water around systems, the savings there, the savings in every aspect of it. We talked about the waste heat, or what was mentioned earlier on, but waste heat is a term used quite often. It's only waste heat if we waste it. There are lots of opportunities, not just heating houses or whatever, but you've got agriculture, you've got a lot of other opportunities to do that. I was in the States recently, and there was a lot of talk about taking the rejected heat and using that to regenerate electricity. So you're getting back to feeding back into, I don't fully understand the technologies or whatever, but they are there and they are viable. So I think it's really important that we look at every single aspect, whether it's pumps, the chillers, the cooling towers, the whatever, and look at how we can make each of those more efficient. And I think that's a holistic way of doing things. It's the only way it can be done. There are savings everywhere you look. We just have to open our eyes and find them.
So, Mother,
So I think you spoke about the COP. So let me put some numbers very clearly. The conventional chillers which are being used, COP is around 3.5 air-cooled chillers. Today you can go beyond 4. I think that's a clear addition what you are getting, which can really be employed. Then, as I said earlier as well, when you start increasing the inlet temperatures, I think again you keep on adding, like every degree you increase, you save power by 3%. So this is a clear advantage which the chip manufacturers can look into, and the rack manufacturers. So when you keep on increasing the temperature levels, every 1 degree will clearly give you that advantage. I think Liam also spoke about, I think, utilizing waste heat. We have done a good project in our campus itself, where we are recovering the waste heat, which I think in the Indian context today, data center is seen as a different entity. Now, how to utilize that heat? Somewhere government infrastructure has to come in place. Because if we start doing that, then that waste heat can simply be utilized by the hotels, hotel industry, because they need hot water. I think a clear example, and this is what can be demonstrated today. It is being done by the process industry because they have everything in-house. So if we start combining these two things, there is a name to that, sector coupling. So if we start doing that, I think the efficiencies of the systems can be multifold.
is that something which is seen in the APAC region, Roy?
I think in just looking at what the other speakers have said, right? So looking at how efficiently we can use the waste heat is very dependent on which country you're in. So you need the need or the requirement for that heating where you can put it to be established first. There are attempts being made regarding that as well. I think the other thing is that a lot of government regulations is going to drive sustainability. And if you look at in Europe, you have the European directive, which sets very, very clear guidelines as to what DC operators need to do. And I think, I'm not quite sure about the Indian regulations, but places like Singapore, etc., they have very, very tight regulations in terms of energy efficiency. And data centers, because they chew up so much of the energy, will come under more focus. So that's what we're seeing in APAC. And as I said, APAC is expanding very, very fast. Thank you.
Thank you. Christopher, you said you are working on something in Madrid, right? You are working in Europe for your new designs.
Yes.
Is the heat recovery a very common technology used there?
It's certainly it's in design more. It's becoming more requested. Like so, I suppose one of the obstacles is the cost. There's a huge cost involved in apart from, let's say, gathering the heat that's being rejected by the data center and going into a very, very large heat exchanger building. So there's a large cost there, and the conversation is at the moment who's going to fund that. So there's no doubt that the DC developers are coming to the table and looking to fund it. Also, the local community and the local councils are looking to fund it as well. So, but that initial cost is an obstacle, there's no doubt. But it is becoming more and more common. It's more common, definitely, I think, in Scandinavia and some of the northern countries where there's a much bigger requirement. So obviously you see a return much more immediately. In some of the countries in mid-Europe, where we are in Milan and in Madrid also, it's less, let's say, urgent, if I can say, because there's less of a requirement. You have a limited number of months of the year where it's useful. But it's something that is definitely being spoken about concurrently with all DC developments.
If I can add to that, because I work in Europe an awful lot, a lot of what we do is local to me. It's a mindset, and if you look at data center operators, some of them are very, very keen. They will find opportunities, they'll find aquaculture, agriculture, local communities, swimming pools, things like this, and it gathers momentum. It really does. And some governments and some local authorities are making it, I wouldn't say mandatory, but you have to have a very, very good excuse not to do it. So you have to prove that it's just not viable. And I think if you really look hard enough, it is viable in most situations. It doesn't have to be district heating. And that's the challenge. People think about district heating. There are lots and lots of other opportunities. And they're not just in Europe, they are local, so we can find them in other places as well.
Yeah, so that's my next question. Given that we typically have higher temperatures here in Mumbai, but with the new elevated operating temperatures of the data centers, is it still a good option, the heat recovery thing in Mumbai? Any thoughts?
I would suggest that, as Liam is saying, if it's not the primary one, it has to be there. We have to start looking at other options and how can we reuse. Because there's so much energy being generated and being used by a data center that there's no doubt that the reuse of some of the energy that is being rejected by the technology has to be brought into the equation in terms of what can we do.
I think it's part of planning. If you plan to build a data center beside a textile factory is going to want hot water. You're not going to give them the temperatures they want, but you're halfway there. So there's less energy needed to bring it up to the temperatures they need afterwards. So it's this mindset of thinking, how can we all work together on this? And from a community point of view, it makes sense.
Yeah, another addition to this is, with the increase in the temperatures, another concept which can be very well utilized is free cooling. Because you can simply use the water, which is at a normal temperature, to probably cool in the night. Obviously, it will be for a few hours, especially in a place like Mumbai, and maybe for a few months only, but still it can give an advantage to us. Yeah.
Great. So I think we are running out of time. Let me ask a final question to all of you. What kind of cooling technologies we would be using in 2030? Are we all agreeing that it will be this technology, or there could be many variants still coming in? What is the thought process here?
I think I'll go first.
Yeah, please.
Just quickly, I said this earlier. It will be liquid based, okay, based on the demand that's coming along. How we go from the hybrid to immersion, which is the dream of all engineers right now. So as far as I can say, we'll be significantly there in 2030. Absolutely, yeah.
Your thoughts there?
I'm hearing a lot of direct-to-chip and various formats, so two-phase direct-to-chip going into refrigerant as well. So this has been driven once again by the chip manufacturers. When you're getting up to the GPUs of sizes they're talking about, we need to find new technologies, and refrigeration looks like it's probably on the line.
Yes, your thoughts.
Yeah, I think as both the speakers have already said, I can clearly see that we are moving in that direction where we are going to utilize direct-to-chip in one or the other ways. And obviously, to even utilize that, you need refrigeration and air conditioning. That will always be there, but direct-to-chip clearly is probably the way to go.
Yes, Rajkumar.
Yeah. So I see a multi-phase, both from multi-stage and multi-phase based cooling in 2030. And more importantly, I have a strong feeling that the leveraging brine or seawater, right, will be something that people will develop by then. And I'm quite positive about it.
Interesting. Yes, Christopher.
Yeah, so I would agree. I think some of the emerging technologies that we're seeing outside here, the direct-to-chip cooling looks like it's the way to go right now. But I'm not a gambling man, so I'm going to hedge my bets. And I will say that I read recently that the last great invention that we will ever make is AI. So it's a very exciting time ahead of us in the next 5-6 years to see what AI will come up with in terms of how to cool these data centers better. Very, very interesting time to be in the industry.
I think we are almost at the end. Can we have a couple of questions if there are any? Yeah, we have just time for a couple of questions if anybody has anything. Yes, sir. Gentleman in the front. Do you have a mic for him? Do you have a mic for him, please? Thank you.
So my questions to all the gentlemen that, how do you see the data center building on a star labeling? On an energy efficient front or on a renewable front or on a decarbonization front? So that's my question.
You mean the building part of it, the civil
Yeah,
structure?
building star labeling for data center.
Well, I think by default, all data centers, as we all said, are designed for energy efficiency because it makes a lot of business sense. Renewables now are becoming mandatory anyway, right? So, and probably the grid instability or inefficiencies or the demand, that also is one factor which will drive renewables. So I think going forward, we will have more and more efficient and sustainable data centers for sure.
How about the star labeling for the buildings? Like
Star ratings.
Star ratings.
So I don't know if you were there in the morning. IGBC CII has published a data center, green data center rating system in India, and they have a criteria for various levels of green, right? They also have guidelines around how to make it better in terms of sustainability. I think there are some green mark standards already in Singapore, some other marks in Europe. So I think they are all there. The thing is, they are not mandatory as of now. They are voluntary, and data centers may opt for that, may not. But at least, again, I will quote the gentleman here from the Maharashtra government in the morning. I think there are some minimum criteria now to establish a data center. I think a similar one in Singapore. Please elaborate that.
In Singapore, it's mandatory, by the way. So if you go there and want to build a data center, you've got to follow all the requirements, and they're very, very stringent. So, just to look at, you've got to maintain a minimum PUE of 1.3.
Right.
Okay, and a lot of the data centers, particularly in Singapore in that region, we are running at 1.1, 1.2.
Right.
So it's going to push that, but I think legislation is very important.
Yeah.
When, unfortunately, developers, etc., when they have an option and it's a guideline, the first question they will ask the consultant is, do we have to comply?
Yeah.
All right, I think there is a place for regulations to a reasonable business sense, I guess. Thank you.
Thank you so much.